class in Math Academy, and today we have a question on the board that says we should differentiate y is equal to x squared plus 1 to the power of x. So this is a pretty simple question, and to solve a question like this, we need to approach it by taking the natural log of both sides. The natural log of both sides. This will become y is equal to x in x squared plus 1. Now this is a question where we have the left hand side, we have the right hand side. Right hand side is the left hand side. Yes. Particularly look at the right hand side first and try to differentiate this right hand side of the equation. And to differentiate the right hand side, we are going to apply chain rule. But still, we are going to use the product rule. And recall what the product rule states, that I have this is equal to u the v over the x plus v du over x. That's what we're going to apply to solve the left hand side. Let's call this equation 1. You can see from equation 1, the right hand side of equation 1 will be from right hand side of equation 1 we solve that by differentiating the right hand side of equation 1 using the product rule. We have this, that let's put up what we are trying to differentiate, that x in x squared plus 1. From there we could see that our u is equal to x and our v is equal to ln x squared plus 1. Our u is equal to x, therefore u over the x, du over the x, that's differentiating u with respect to x, is going to be 1, and differentiating v with respect to x, differentiate this v with respect to x, this is what we're going to have. We're going to have this. And this is what we want to particularly look at now. First of all, let's look at how we're going to differentiate this, because we need all these parameters to fit into this equation. We know what our u is, we know what our v is, we know what our du dx is, so now let's know what our the v dx is. Okay, so moving forward, we need to find out what the v over the x is. That means we're going to differentiate v with respect to x. Permit me to call this equation 2. What was our last equation? Permit me to call this equation 2. We can say from equation 2 From equation 2, this is the equation I'm referring to in this equation. In equation 2, we have, you can say, let u equal to let u equal to x squared plus 1. Why am I saying let u is equal to x squared plus 1? I want to be able to make this easier for me to differentiate by calling this u, so that I'm going to have ln u. That is, substitute what this is, which I've now called u. So I'm now left with ln u. Right. So if we differentiate ln u, that is to say we want to differentiate in u, we're going to have 1 over u over the x. Recall differentiation, if we differentiate ln x, go to 1 over x. So that's why if I say ln u, I will have 1 over u. Okay, so what's the next thing I need to do? I know that my ln u is equal to 1 over u du, so I can still proceed now to differentiate this. What was our u? This will now be 1 over, our u was what? X squared plus 1. Our u was x squared plus 1, and then the x squared plus 1 over dx. What I just practically did was to substitute the value of u into this. So that gave me 1 over x squared plus 1. And what was our u again? X squared plus 1 over dx. Moving forward, I need to now differentiate this properly. This is going to give me 1 over x squared plus 1. Now differentiate x squared plus 1. That's going to give me multiply by 2x plus 0. So if I differentiate x squared, I'm going to have 2x raised to the power of 2 minus 1, which is 2x raised to the power of 1, which is the same thing as saying 2x. Then if I differentiate a constant, which is 1, is equal to 0. So this brings me back to saying 1 over x squared plus 1 multiplied by 2x, which is the same thing as saying 2x over x squared plus 1. You can call this equation 3. What I just achieved was differentiating. What I just achieved was looking for this. Differentiating v with respect to x. That's just what I achieved. Therefore, the v for the x is equal to 2x over x squared plus 1. Alright, so now we know what x u is, what v is, what du dv is, what du dx is, and what the v dx is. For reference sake, I'm just going to put it down here again. That's our u. What also are u? Let's look for what u. where u was equal to x, our u was equal to x, our v was equal to ln x squared plus 1, and then our du over the x is equal to 1. Therefore, the v over the x is equal to, that's what we just derived now, and that was 2x over x squared plus 1. Yes, 2x over x squared plus 1. Okay, let's use this to now solve the question further. We're using the product rule. The v uv over the x for what it is, it's saying that that's equal to u the v over the x plus v du over the x. So this will give you, our u was what? Let's look at our u. I think I should just write it down here so that we don't screw up and down. Our u was equal to x, our du dv equal to 1, our v equal to ln x squared plus 1, the v over x was equal to 2x over x squared plus 1. Let's substitute, and that's going to give our u was what? X multiplied by dv over the x is 2x over x squared plus 1. Our v is ln x squared plus 1. And then our du over the v was 1. Multiplying this through, this is going to give us 2x squared over x squared plus 1 plus ln x squared plus 1. Let's call this equation 4. All I just achieved was the right hand side of equation, or just the right hand side. Go back. What I just achieved was differentiating this, or just what I achieved, and that gave us what we had here. I'm going to recall this equation again. Let's recall it. Let's recall equation 1. Let's recall that equation 1 that says ln y is equal to x ln x squared plus 1. So that was our equation 1. So what I just achieved in equation 4 was differentiating this right hand side of equation 1. What about the left hand side of this equation 1? If I want to differentiate, I also need to differentiate the left hand side too. So let's get equation 5 by differentiating ln y. So I can then say from equation 1, which is this equation 1, equation 1 as this equation, that's what I'm recalling. From equation 1, which was ln y is equal to x ln x squared plus 1. If we differentiate the left hand side, we have that ln y Want to differentiate that? Want to differentiate ln y? It's given by sin 1 over y over dx. Still recall, if you differentiate ln x is equal to 1 over x. Differentiate ln y is equal to 1 over y. It's a standard. That's a standard. One of the standards of differentiation. Another standard we have is, all these are standards. So if you have differentiating a constant k, you have 0. All these are standards for differentiation. So that was how I got that ln y is equal to 1 over y dy dx. So now let's equate the both of them. So now we know what we can call this equation 5. So we know that our ln y is equal to 1 over y dy dx, and our x ln x squared plus 1 is equal to this we got in equation 4. Then we equate the both of them. Therefore, 1 over y dy over the x is equal to 2x squared over x squared plus 1 plus ln x squared plus 1. Why am I equating the both of them? That's just what equation 1 is saying. Equation 1 says that we have equation 1 is ln y is equal to x ln x squared plus 1. That is to say, I have to differentiate the whole of this. By differentiating it, I got the left hand side is this. By differentiating this, the right hand side is this. So both of them have to now equate the both of them. So that's just what I'm doing there. After equating that, we can proceed further to say, I can call this equation 6. From equation 6, I can multiply through equation 6 by y. If I multiply through by y, multiplying through by y, it's to have the y over the x will be equal to y. Why am I multiplying through by y? It's just to make the y over the x the subject of the formula. Okay, so this is not going to give us y into 2x squared over x squared plus 1 plus ln x squared plus 1. This is now the y over the x is equal to, what's our y? From the given equation, we know what y was. Let's go back to it. Okay, look at it. Y. See what our y is. We have the value of y. So that's what we're going to substitute back into the equation. So this now have us to say that our y, let's do it this way, but y is equal to, that was x squared plus 1 to the power of x. Therefore, when we substitute that, we're going to have that the y over the x is equal to x squared plus 1 to the power of x multiplied by 2x squared over x squared plus 1, and we have ln x squared plus 1. And that becomes our final answer. So final answer to differentiating y is equal to x squared plus 1x is this. If you have any questions, feel free to ask in the comment section, and I'm going to reply to it and give you a more clarification on where you seem not to understand. If you have any other question you want to solve, don't have an understanding of, you can also put it in the comment section, and I'm going to make a video solving that question for you.